So today I will talk a little bit about my key area. It's a topic of my PhD thesis, and it's one of the main areas that I work in at the European Library, which is information extraction. Well, first of all, let me say that my background is in computer science and information systems. So I'll try to talking for a computer scientist to talk about information extraction in 15 minutes is quite difficult. So I'll try to focus on the very general topics that are most relevant when we are thinking about applying information extraction to metadata. And I will talk about the named entity recognition and the entity resolution, which are two particular cases of information extraction and which are, let's say, the ones I see as most relevant in this context of Europeana. So I'll address what are the key challenges for applying these processes in metadata records. And I'll give some examples of tools. I'll talk a little bit about one of those tools, which was an outcome of the Europeana Connect project, which was the GeoParser, and then just end with some general conclusions. So information extraction, so this is about picking up text which humans can read and understand and interpret, but computers can only display it to the end user, or maybe allow to search on it on a search engine, but they can't really understand what's written in there. So information extraction tries to take that text and put it into a structure that computers can process in more detail, with more specific semantics, which will allow the computer to do a bit of reasoning on what it actually means and how it can be used. So as the outcome of an information extraction process, you'll end up with some very well-structured data with a very well-defined data model. It can be RDF, it can be a relational database, etc., or XML, something like that. Something that a machine can understand all the semantics of what is in there. So this is this area is a topic of research in the area of natural language processing, where tools address how text is tokenized, how the words are separated from each other, from the punctuation marks and so on, locating where the verbs are, and analyzing all the grammatics of the sentences and so on. So a specific case of information extraction, which is very relevant for in the Europeana context, is named entity recognition. So in this case, we have the unstructured text in natural language, the sentences we all understand very well, but computers don't, and we try to locate within the text mentions to entities, to names of places, names of persons, names of organizations, subjects, and so on and so forth. So named entity is about recognizing where it is in the text and what kind of reference, what kind of entity it is. So this has been very well researched in the natural language area. And these tools work by processing the lexical evidence, so they need to know the source language that the text is in. They do a very fine, detailed analysis of the grammar of the sentences, and then they extract where the names of the entities are. So, and the tools that are available for doing this, they do it just nearly as well as a human being in well-structured text. So they can interpret the sentences very well and recognize the entities. So this process is named entity extraction is very relevant. Some studies on the internet search engines have revealed that at least 70% of the queries that users make on search engines are about an entity, a person, a place, etc. So by locating the references to entities, in data, in the text, and we can give it more relevance for searching or for browsing, etc., and improve the user experience. Named entity recognition is very often used in conjunction with entity resolution. So entity recognition, we just identify where the names are and if they refer to what kind of entity it is, if it's a person or a place, or for example. But it doesn't go as far as saying which exact person it is. So entity resolution, it goes from the name and it tries to actually figure out which precise person it is referring to or which exact place in the world it is referring to. So this becomes extremely relevant in the context that we have been mentioned here lots of times already of open linked data. The linked part of open linked data is entity resolution. So it's trying to figure out in our data the names of persons we have, for example, what is their correspondence in VIAF, or the names of places, what is their correspondence in geonames or other geographical data sets. So this is another very important information extraction process. It's also very important in the context now of EDM, where we can express these links to these open linked data sets in our metadata. So when we try to apply this in metadata records, we find the problem that the techniques are based on natural language processing, and when we apply to metadata fields, we don't have the same kind of text. We don't have well-structured text. So it has not enough evidence for these tools to work well. And in particular, in the case of Europeana, we have a very large number of languages, which make it even harder to address, because each of these tools needs to be specific to the language being processed. And so it's difficult to find tools for all of them. So here we find an example of a metadata record. I need to speed up, but you can see, for example, in the table of contents, there are many, many entities being mentioned there, but we don't have really good sentences here. So if we send this text to a named entity recognition tool, he will miss lots of them. So the same thing we can see here in the DC terms spatial. We have references to places in there, but they are not in a well-structured sentence. They're just textual expressions. So some of the available tools. Gate is a general purpose tool that has been used a lot. It's probably the easiest one to use, very pragmatic. It's not really the top, doesn't apply the top techniques from research, but it's very pragmatic and provides good, easy to use interfaces and so on. Then we have two open source tools to perform named entity recognition, one from Stanford and another one from the Apache Foundation. One from Stanford is actually one of the top state-of-the-art tools for this, and it's available, trained already for English and German. So we have special tools for geographic information. One of them is Yahoo Placemaker and the Europeana Connect GeoParser, which will be shown tomorrow in the marketplace. So if you want to know a bit more about it, we can go. You can just show up there and make you a demo. So basically, the GeoParser tries to process metadata records, locate the names of the places within it, and then make a link to geonames so that we know exactly which Lisbon we are talking about in the metadata record, since there are many over there in the world. So we tried actually to compare this tool with the Yahoo Placemaker. We made a test collection, and it actually proved that when we try to apply these tools to metadata, they have problems, mainly in the recall. That is, they miss a lot of entities. They can't recognize it because there is no well-structured sentences to help the tool to identify the names of the places. So just to conclude, so these tools are very, they work very well in well-structured text. When applied to metadata, they don't work so well. They are language dependent, so lack of good sentences is also a problem. And these are probabilistic tools usually. So they try to guess, let's say, when they extract the information, they use probabilistic models to extract the information, but there is a certain level of uncertainty. And usually they give you a probability that they are right or they are wrong. And we need to adjust our tools that take the output of these tools, use that probability and see if for our use case we can use that information or not. So if we recognize a place with a very low probability, if we just want to index it, maybe it's not a problem, but if we want to actually display to the user, allow him to navigate, maybe we only want to take those entities that were recognized with very high confidence. So thank you. Any questions?